So again, we are saying solving this Bernoulli differential equation. Our first step is to write this differential equation in the general form. So we are saying we have a general form. Uh, we are saying dy upon dx. Uh, Added that to p of x, y should give us a q of x, y raised to the n. So our second step is to find our p of x. So let's find our p of x. Let's find our q of x. So we'll again find our n. We'll again find our mu of x. Then we find our general solution. Okay, so these are the steps we will be looking on. So our first step, once we have already written these Bernoulli this differential equation in this form, so we are saying y to the first prime is just saying as dy dx plus 3x squared y equal 4x squared y squared. So we can relate from this. So this is dy. Okay, so from this point we are saying p of x is just 3x squared. So it's just 3x squared. Okay, from this point we are saying what's our q of x? 4x squared. Q of x is 4x squared. Then our n should equal 2. So let's find our mu of x. So we find our mu of x. Our mu of x, we're saying mu of x is just e to the integral of 1 minus n. Multiply that by p of x dx. So let's calculate the integral. So we're saying the integral of 1 minus what's our n? 2. Okay. So p of x. So what's our p of x? 3x squared dx. So we are saying this is just the integral of negative 1 multiplied by 3x squared dx. So from this point, let's take out our constant. So we are saying this will equal to negative 3, the constant x squared dx. Solving for this, we are adding 1 to the power divided by the result of that. We are saying should give us negative 3 multiplied by, if I add this, I should get x to the third divided by 3. Okay, so this 3 cancels this 3. I should get negative x to the third plus a constant of integration which we won't include as much in these calculations. So we are saying our mu of x equal e raised to the integral of this, but we have already computed this integral as negative x to the third. So this is our mu of x. Our mu of x equal e raised to negative x to the third. So that's our first step. So our second step, let's solve for the general solution. So we are saying the general solution. The general solution is in the form we are saying y raised to 1 minus n should give us 1 upon mu of x. Multiply that whole expression into we're saying 1 minus n multiplied by q of x multiplied by mu of x, added that to a constant of integration. So we are saying, so let's perform this. So this is just y raised to 1 minus 2 should give us 1 upon, so what's our mu of x? Our mu of x is e raised to negative so it's e raised to negative x cubed. Then I'll multiply that whole expression with 1 minus 2. I should get 1 minus 2. Okay, multiply that by q of x. Our q of x is 4x squared. So 4x squared multiplied by mu of x. Our mu of x is e raised to negative x cubed plus a constant of integration. So simply we're just substituting whatever we had. So from this point we are saying, continuing this step, we are saying I can write this as just e raised to x3 multiply that by whatever is in this bracket. So remember, sorry, we should have an integration sign here. We should have an integration sign at this point. So we should have an integral sign at this point. So we're taking the integral of the whole expression. So if I take this and minus this, I should get negative 1 multiplied by, if I take this, I can write it as 4x squared multiplied by e raised to negative x cubed plus a constant c. So how will we take the integral of this? So we are tasked by the process of taking the integral of this. So we are saying we are taking the integral. So let's solve for the integral of negative 4x squared multiplied by e raised to negative x raised to 3 dx. Remember there's a dx at this point. So there's a dx. So we're integrating with respect to x. So we should have a dx at this point. Okay, now, so we're saying this dx. So how will we take this integral? So number one step, I have two steps. So we have number one and number two. Number one step, we can use substitution. Okay, of which in this tutorial I will use the substitution, and we can use integration by parts. Okay, integration by parts. Because we are conversant with integration by parts, I'll use the substitution method, where I'll say let my u equal negative x cubed. Okay, so if I get my du, I should get negative 3x squared. Okay, dx. So if I solve for my dx, I should get dx should equal du upon negative 3x squared. So if I replace all these expression to this integral, we are saying this is the integral we are performing. So let's say now the integral of negative 4x, okay, squared, multiply that by e raised to my u that I've indicated as my u, then I'll multiply my dx as du upon negative 3x squared. Okay, so as you can see, this negative cancels this negative, this x squared cancels this x squared, so I'll remain with the integral of as you can see, I'm remaining with 4 over 3 e raised to the u du. So if I perform this integration, I'll take 4 over 3 outside the integral, then I'll say integral of u du. So if I perform this integration, so we are saying integrating an exponential function, I'll just write the exponential function. So I'll write 4 over 3 multiplied by the exponential function itself, e raised to u, multiplied by the divided that by the derivative of the power, which is 1. So if I divide by 1, it will remain this. So I should get 4 over 3 e raised to u. If I substitute back my u, I should get 4 over 3 e raised to negative 3. What's my u? My u is negative x squared. So this should be negative x squared. Okay, so I should get negative x cubed, sorry, so it shouldn't be. So this is my answer. We have already performed the integration to this. So we are saying my answer, remember we were dealing with this, so our answer, we are saying y raised to negative 1 should give me 1 upon we have said 1 upon mu, but what's our mu? So we already written this as e raised to the third. Okay, so it's saying e raised to the x to the third, then I'll multiply that by the whole the whole thing in this. So we are saying we have already performed this integration at this point and gotten it as 4 upon 3 e raised to negative x cubed. Then I'll multiply this by that, then I'll add to the constant of integration, remember. So we have our constant of integration at this point. So we are saying, so our answer is if I take this and distribute it inside, I'm saying this is just 4 over 3 multiplied by e raised to the third x to the third. If I multiply that by e raised to negative x cubed, then I'll add that to e raised to the x to the 3 multiplied by a constant of integration. Okay, so from this point, as you can see, these powers using the laws of natural logarithms, we're saying these powers will cancel out and will remain with a 1 at this point. So I'm saying this is 4 over 3 multiplied by 1 plus c e raised to the x to the 3. So we're saying our answer is 4 over 3 plus c e raised to the x 3. These are 1 over y. So for us to solve for the y, so already these are general solution. Okay, so these are general solution at this point. So for us to solve for y, we're saying y equal, if I make a common denominator to this, okay, so let's make a common denominator using the LCA value. So we're saying this is just 4 plus 3c e raised to x 3 divided by 3. Okay, so if I say let 3c equal c1, okay, so we are saying this is 4 plus 3c is c1, then e raised to the x third divided by 3. I should get it as my y. Okay, okay, this should be not y, this should be 1 over y. Okay, so for me to get my answer, I should get, if I take the reciprocal to this and say y should give me, the reciprocal to this is just 3 upon 4 plus c1 e raised to the x 3. Okay, so these are my general solution. Okay, so please like, share and subscribe to my channel. Have a lovely day. And note, please let me get you back. So we're saying we have two methods on solving this. So we have used the substitution method, okay, but also you can use the integration by parts method, because as you can see, this is just an algebraic function, and this is an algebraic function, and this is an exponential function. Okay, so please like, share and subscribe to my channel. Thank you for watching. Have a lovely day.